Mollusks are the most abundant of aquaculture products in the world. In Southeast Asia, there are 3 countries that are actively interested in marine mollusk farming, which is Thailand, Malaysia, and the Philippines. One of the most important commercial species landed are Asian green mussels, 𝘗𝘁𝘳𝘪𝘥𝘪𝘴 viridis. However, mollusk landings in Southeast Asia vary year to year, until annual production in the region has actually decreased. It decreased because it has been influenced by a number of causes, which is inconsistency in unavailability of seed, intensive exploitation of culture site that resulting in a shortage of suitable regions for future development, demand levels below production capacity, pollution and natural occurrence. Since most Southeast Asian countries have large endowments of similar mollusk species and acceptable natural conditions for their culture, the state of development and economic significance of the shellfish industry may differ. The farming technology of most mollusks in the region relies on conventional methods to collect sperm from the wild for transplantation to cultivation areas, but cultural practice have been gradually and systematically improved over time, such artificial breeding techniques for Asian green mussels, 𝘗𝘁𝘳𝘪𝘥𝘪𝘴 viridis, with the aim of increasing production through sustainable management practice.
Now I will present about the procedure or method on conducting artificial breeding for mussel 𝘗𝘁𝘳𝘪𝘥𝘪𝘴 viridis, or also called as green mussel. Okay, first is broodstock selection. Healthy and strong 𝘗𝘁𝘳𝘪𝘥𝘪𝘴 of physique of male and female mussel are selected as the parent, which are more than 3 inches of and is individually big, with complete nothing of shell is damaged, and the shell surface color is smooth, trailing edge is roomy, stout and strong, the nothing's morbid state of soft body, and lastly the gill lamella do not have that wound is scarce. Okay, in picture 1 you can see the examples of suitable broodstock of 𝘗𝘁𝘳𝘪𝘥𝘪𝘴 viridis. Okay, number 2 is temporary storage. After we have selected the male and female parent of mussel 𝘗𝘁𝘳𝘪𝘥𝘪𝘴 viridis, we need to place them in a freshwater mussel pond, and as we can see in picture 2, this is the examples of a good mussel pond for the male and female parent that we have chosen. So before mating season, this female and male parent is spotted in the 1 to 10 freshwater mussel pond, pure and fresh in water quality, that the soft oxygen is sufficient and the food organism are abundant. The next step is injection of female broodstock. So the female broodstock that we have selected are injected by human chorionic gonadotrophin (HCG) with 1000 units. So in picture 3 we can see the example of injection of hormone in bivalve, and also can be done with mussel. In mating season, presiding about 10 hours of artificial insemination prerequisite in female freshwater mussel abdominal seminal fluid intramuscular is injected by human chorionic gonadotrophin (HCG) with 100 units and then is moved temporarily in the storage pond. Okay, fourth is sperm collecting. As we can see in picture 4, this is the example of procedure of collecting sperm in mussel. Male freshwater mussel gonad crust is cut with scalpel, as we can see in the picture, and then stretched into the gonad from pouch with suction pipe, and then we can take the seminal fluid. Next is instillation in female. The sucking of seminal fluid that is taken from the male and sodium chloride patch with 0.4% is instilled in the female freshwater mussel at the mantle cavity immediately towards ray for 10 times. Okay, so in picture 5, we can show the location of mantle cavity where the seminal fluid and the sodium chloride patch is instilled to boost the egg production in female mussel. 6. Fertilization. After 5 to 6 hours, treat that female freshwater mussel is induced by seminal fluid to discharge the mature egg cell after. Carry out second time seminal fluid according to same method and instill. Combine with the mature egg cell with the assurance sperm and be fertilized successfully. Lastly, collecting of young mussel. The female freshwater mussel of artificial insemination success is moved into storage pond. Holding pond supports temporarily to hook larva maturation. By shot, it's discharging larva of exposure in sunshine and with yellow catfish as host. Take off seedling and young freshwater mussel is cultivated. So we can see in picture 6, it is the example of young mussel that is attached to a fish gill filament.
Hi, my name is Muhammad Fazrin. I'm going to present the discussion part of our presentation. First of all, what I want to highlight is that this 𝘗𝘂𝘳𝘪𝘳𝘪𝘥 will be spawning after 2 hours of temperature, stabilization from 18 to 30 degrees Celsius. Next, the male mussels first discharge sperm as a smoky stream, while the female mussels release millions of orange-colored eggs, describing the optimal temperature regime for induced breeding and spawning of tropical green mussel spawn. We move on to the next slide. Stated here that 𝘷𝘪𝘳𝘪𝘥𝘪𝘴 larvae 2 days old were placed in 5 30-liter tanks, 4 with antibiotic treated FSW and 1 with natural seawater as a control experiment, plus penicillin, streptomycin, a combination of penicillin and streptomycin and chloramphenicol were used in the experiment, each at a dosage of 0.02 milligram per liter. Next, here stated that the antibiotic solution was aided and vigorously aerated before the 𝘷𝘪𝘳𝘪𝘥𝘪𝘴 larvae were moved to the appropriate larvae rearing tanks. Antibiotics were also added during the change of the entire volume of water every 3 days in the culture tanks. So the seawater in the control tank was also changed daily. Furthermore, density in the tanks was 6 ml per liter in a total of 180,000 larvae in each tank. We move on to the Next slide. The larvae were fed leaf cultures of the algae from the second day, when the D form was achieved, to the seventh day, when the larvae were fed 5 species of the above-mentioned algae mixture. As the larvae matured, algal densities steadily increased from 2.28 to 3.50 times 10⁴ cells per milliliter until the 18-day rearing period. The monthly mean variation of water temperature in this mussel hatchery ranged from 27.4 to 30.6 degrees Celsius, for the salinity from 30.1 to 31.48, for the dissolved oxygen or DO from 5.04 to 6.5 ml per liter, and the pH is from 7.7 to 8.4. The larval stage lasted around 3 weeks, and the larval reached a shell length of 300 to 400 micrometer. Plus, they are known as eye spot larvae or pedivillagers at this stage because they have developed an eye spot as well as a foot in addition to the venom. As an addition, larvae swim using their velar cilia and crawl with their feet at this stage. The volume shrank and was replaced by buds that would later become the gills. Next, the average shell length was 332.83 or 10 plus minus 10.34 micrometer on day 18. We move on to the slide 6. After the larval stage, it transformed into benting stage, which is a crawling benting stage ready to attach to the substratum. Next, among the 5 tests, the larvae administered with a mixture of penicillin and streptomycin had the best development, survival, and growth rates. In aquaculture, benzylpenicillin and streptomycin are permitted. Larvae also treated using a mixture of penicillin and streptomycin. Lastly, here is the statistic of average shell length mussel larvae over 18-day rearing period when inoculated with different antibiotics. That's all from me. Thank you very much.
In conclusion, it is clear that it's important for the difference and mastery of 𝘗𝘧𝘳𝘪𝘥𝘪𝘴 artificial breeding skills. Breeders must learn more about the breeding method of this organism. With the correct and orderly artificial breeding method, can increase the sustainability of this species to be more stable in their habitat. In addition, breeders can also demand of consumers who want to enjoy this food. The various methods of artificial breeding this species of 𝘗𝘧𝘪𝘥𝘪𝘴 require a bit of time and require many steps but can be overcome by breeders with the study and development in the artificial breeding of this species. Finally, we must be thankful the researcher is able to use systematic method in breeding for this organism. Not only what the things experience future extinction, but also stabilize this species so that future generation can test, enjoy, and see the unique species.